Hello everyone. In this video, we'll be talking about the uniform motion. The word uniform motion means motion along a straight line with constant speed. Or in simple terms, if we want to say, the velocity is constant. Getting it? For uniform motion, the position versus time graph will always be an inclined straight line, while as the velocity versus time graph will always be a straight line parallel to the time axis. And acceleration of such a system will always be zero. Okay, so we can deduce few formulas here. Since acceleration is 0, we can write it as null vector in the vector form. D by dt of v is equal to null vector. Do you agree? And dv is equal to dt multiplied with the null vector. Okay. We can integrate both sides. The initial velocity vector is written as u vector, final velocity vector is written as v vector, and then it will become v vector minus u vector is equal to null vector, or we can say that v vector is technically equal to u vector. This v can be written as the rate of change of the position is equal to u. Let us simplify it further, u dt, and now we can again integrate it. When time is 0, let's say the initial position of the particle is indicated with the r initial vector. When time is t, then this final position is indicated as r final vector. Okay, simplifying it, what you will get, r final vector minus r initial vector is equal to ut. This is another important formula, or from here we can deduce that r final vector is equal to r initial vector plus ut. Is it okay? This r final vector minus r initial vector, you are familiar with this thing. What is it? Change in position is known as the displacement. I am writing that here for your reference again. R final minus R initial is the change in position, and change in position is known as the displacement. Done. Simple derivation. You can note it down, and then we can take up question on this. Now let's take up a question on this. Here is the simple statement given for the question, and utilizing this formula, you can find the final position. If you wish, you can give it a try yourself. Okay, I'm simplifying the things here. R final is equal to R initial plus ut. R initial is given as I cap plus 2 j cap plus 3 k cap meter. The initial velocity is also known to us, 2 I cap plus 4 j cap minus 6 k cap meter per second into the time given is 5 seconds. Here the unit second is getting cancelled out, and we can simplify it further. You note it down, then we'll be taking up the next question. Here is the last question of this video. A particle is moving along a straight line with the constant speed 50 meter per second as shown, and we need to express its velocity in the vector form. If you wish, you may pause here and give it a try. Question is pretty simple. Velocity in vector form requires the magnitude as well as the direction, and everything is visible on the board. Okay, I'm starting the solution here. We need velocity in vector form, which has the magnitude 50 meter per second, and direction can be obtained by taking a unit vector along this line. You know how to write this unit vector. Unit vector is vector divided by its magnitude. So first we'll find a vector along this direction and then we'll divide it by its magnitude. Doing that computation here, 4 minus 1 I cap plus minus 5 minus 2 of j cap plus minus 6 minus 3 of k cap. This is the vector. Now we have to divide it by its magnitude. So 4 minus 1 means 3. So 3 square under the root plus this is minus 7 plus k cap coefficient square. When you simplify this, it will be the velocity in the vector form. Okay, this is all about this video. Stay awesome. Take care.